year-round. But everything you put on your periodic table, like I just said, can be used on your test. So the information that I tell you is okay to put on there, you can use on your test, like the numbers that go down the side and the numbers that go across the top. Numbers that go down the side tell you energy level. The numbers that go across the top tell you valence electrons. So those things are fine to put on there. Today, what we're going to add on there are the different, they're called families or groups of elements. So we're going to color families similarly and go over their properties, like properties that they have. And we're also going to cover the three big chunks of elements that are up there. So there's families and groups that we'll talk about, and then the three big chunks. So on your periodic table, you're going to need to put two colors, generally two colors inside of each box that's going to be on there. So what I'm saying is you're going to color each box with two different colored crayons. And you can do that in a number of different ways. Some people shaded the top half one color and the bottom half another color to represent stuff. Some people drew borders around stuff, but what I'm saying is each box is going to get two colors in it. And whatever colors you put on there, you're going to be able to need to read through so you can still see the numbers and the letters underneath the colors. Does that make sense? Perfect. So, first piece I'm going to have you guys add on there are the three big chunks on the periodic table. It's hard to see it with the lights on, but the color stands out a little more with the lights off. And remember, you want to color lightly enough that you can color over it with another color or outline it with another color, whatever. But you want your periodic table to look like this color-wise. Your colors don't have to be the same. And the easiest way to do this is like this. See the biggest chunk of them right here and down here included? Just leave those white. That way you'll know that saves you the most amount of time. So if you could color this diagonal group that goes here and then this group over here, and notice hydrogen is a part of this over here. If you can get those two blocks of stuff colored, we can fill out a key for them here. So you want to get those blocks colored, and then we'll go back and fill out a key for what's what. The different colors you see represent three different clumps or three different types of elements on the periodic table, and there's only three. The biggest group you see, you want a little key off to the side, top center would be a good spot for it because you've got lots of blank space right there. And you can put, just a hollow box, like an empty box, and say that is metals. Right under that, you want another little box and say that that's metalloids, and then a third box to say non-metals. So you want those three things written out so that you can access it when it comes time to take your test. That also, at the same time, makes holding on to your periodic table kind of important, because as you start to put information on there, it gets more important, and if you lose it, you don't have that information on the blank periodic table. So start to find a good spot for it. We'll talk about the physical and chemical properties of these three things. Do you guys remember from 8th grade or 7th grade science what physical properties are? Anybody want to volunteer what a physical property is? No problem. Physical properties are things are they hard? Things you could touch, sense, things like that. Are they hard? Are they soft? Are they light? Are they heavy? Are they dense? Are they brittle? Are they hard? Those are physical properties. And chemical properties would be what they can react with, what kind of chemical reactions occur, which will help us out as we go into our next units that we'll do. So I'm switching slides over here. And this is going to go on page in your interactive notebook, this stuff. So the first things we'll get down, and I wouldn't write what it says because they're all kind of words that might not make sense to you, but I'll put them in words that make sense to you here. So the word metals these are physical properties of metals, that they're malleable, which means you can bend them and shape them into things. So if you know what malleable means, go ahead and write that. If you don't, go with you can bend them, you can shape them, you can move them around. Every metal's like that. You're able to manipulate it and change it. Lustrous means that it can be shiny, you can polish it up to a shine. With the other elements, you can't do that. Ductile, same thing. It means that you can squeeze it into a wire. You can turn it into a wire, so copper wire or aluminum wire or anything like that. And then the last physical property that's true of all of them is that they're good conductors of heat and electricity, which means that if you put hot stuff in an aluminum bottle, the heat goes away really quickly. It conducts it away from it. But they are really good at like passing electricity through them, which is why you can't touch like a power line with an aluminum rod or something like that. Because electricity goes straight through it and into you, but you can touch it with like a plastic rod. Lustrous means that it's shiny, like you can polish it up to a shine, and that's unique for these because you can't do that with other elements. Good with the metal ones? All right, next group we'll do is the non-metals, and that's anything that's not a metal. So it's going to be like gases, like hydrogen, helium, neon, and those things, and also things that are kind of like brittle solids at room temperature. So the non-metals we're talking about their physical property as in their state at room temperature, that they're either gases, like the ones we talked about, hydrogen, helium, neon, and those, or they're brittle solids, which means they're kind of crumbly. They'd be easy to break in your hand. If you guys ever have like a rock of sulfur or a thing of sulfur before, that yellow rock that smells really bad, it's crumbly. The same thing's true for all the other ones up there. They're brittle. And they are poor conductors of heat, which means you can put something hot inside of them and it'll stay hot for a long time. Same with electricity. You can touch stuff that is electrified with it and you don't get zapped. So far we've got two. We've got metals, we've got non-metals, and the non-metals group is the one that's all the way on the top right of your thing. The last one we've got is the one, that diagonal one that goes across, and those are called the metalloids. And those things are a blend of both characteristics between metals and non-metals. So we say that they've got properties of both. They are dull, which means they're not lustrous, they're not shiny or anything like that. So unlike a metal, which is shiny. Brittle, which means they break easy. And then they're called semiconductors. They conduct a little bit of electricity. And they're valuable because they're used in things like computer processors and any kind of electronics that are out there. Those things are the metals inside of there, and that's why stuff gets expensive, because those are kind of hard to find. Color is that it's called the alkali metals, and you'll notice it's right here. It's everything in this column except for hydrogen that's up top. So it's lithium all the way down to francium. You want them colored all the same color, whatever color that's going to be. And then you want a little key that says these are the alkali metals. Yeah, so these are kind of cool in a lot of ways, but the most exciting way for me that they're cool is when any one of these touches water, they're explosive. So putting these things in water, if you can find this metal, and even in air they react, they're explosive. And as you go down, and you start at lithium and you go to sodium and potassium and rubidium and cesium, the further down you get, the more explosive they are, the more reactive they are. And it's because they really, really, really want to get rid of their electron, which we'll talk about here. But those things are all called alkali metals. And for us, in your notebook, they've got one thing in common. You've got it on your periodic table already, but alkali metals all have one thing in common. Can you pick out from your periodic table what the one thing that alkali metals all have in common is? Randall? Yeah, very good. They've all got the same number of valence electrons. How many valence electrons do alkali metals all have? One. So I would put that in your notes for sure, like in your notebook, that alkali metals all have one valence electron, and that they are extremely reactive. Like these things they'll react with almost any element out there. And I'll give you an example of that as you hear. The next group of metals we've got is right next door to them, and those are the alkaline earth metals. So again, you want to use a different color and make a key somewhere on here, so you've got a key for all these colors so you know what means what. But these are the alkaline earth metals. And these are not reactive in water, unfortunately. You can chuck these in water and they're going to sink. They do, though, do some neat stuff. Each one of these different metals, when you light it, glows a different color, like it burns a different color. And for that reason, these are what are used in fireworks. if you've seen like the big, they call them mortars, the really huge fireworks that go off at the 4th of July, like the ones that they don't let people mess with unless you have a permit or unless you're being illegal, like my neighbors. Those are the metals that cause those when they go off, and you see like the pretty reds and the greens and the whites and the blues. What's causing those colors is those metals burning. That's what causes those different colors in there. So little chunks of metal that float through the air and burn their way down is what you're seeing. So those are the alkaline earth metals. And in your notebook for the alkaline earth metals, we want to write that they've got one thing in common. What's the one thing that all the alkaline earth metals have in common? Cole, what's the one thing these things all have in common? Close. Skylar, what's the one thing these are all going to have in common? Think back to the last one. They all had one thing in common. Do you remember what it was? Did you write down what it was? So close. Cole, how many? Two. Yeah, so these guys all have 2 valence electrons in them. They've got 2 electrons on the outside. That's what they've got in common. And you're going to notice that all the way across. As we go through these, everything in the same family has the same number of valence electrons. And that's why they're called families, because how you react chemically is controlled by the valence electrons that you have. So you guys all right with the first 2? Alkaline and alkaline earth metals? All right. Next group is all these ones in the middle that we're not going to worry about. You'll deal with them in chemistry. The reason we skip them here is because they have, you know how we talked about energy levels with electrons in it, and they all have 8? These ones in the middle are the exception. They don't have 8. They've got suborbitals in them, they're called, and they don't adhere perfectly to this rule, so it makes it difficult to process at like a freshman level. But when you guys get to chemistry, you'll definitely deal with those things. So the middle ones are called transition metals. So I don't know why this blue one isn't colored in, or this clear one here isn't colored in, but you can color all the short ones in on yours. And those are called transition metals. So I'll say that again. These next groups, from boron to thallium, I think is one of them, from carbon to lead, from nitrogen to bismuth, from oxygen to polonium. Those are your different groups. And just like alkali earth metal or alkali metals have a name, these guys are named after the first element in their group. So this one's the boron group, the carbon group, the nitrogen group, the oxygen group. And again, in your notes, if you want to, you can indicate that everyone in the boron group has the same number of valence electrons. Everybody in the carbon group has the same number of electrons. Same with nitrogen, same with oxygen. Next group we got is the next to last group. It's the one with 7 valence electrons in it, and they're called halogens. So it starts right there with fluorine and goes all the way down to, I think it's astatine is the name of it. Yeah. Astatine. There it is. So it's this group. They're called the halogens. And if you look at them, you'll notice that they've all got 7 valence electrons, which is really close to the 8 they want to be full. So these things usually bond with these guys over here, the ones that are explosive in water, and they form these things that are called halides, or salts. All the way on the right, I won't switch the slide over yet for people still looking at this, but the ones all the way on the right, from helium down to, I think it's radon? I should know that. Yeah, so helium down to radon, those are called the noble gases. And those are unique because every other element on the periodic table will bond, they'll like react with other elements. But the ones all the way on the end, the noble gases will not react. Can I slide this slide over? Okay. All right. So the noble gases, which are all the way on the right, are not reactive. So that's a note you want to write down on those in your interactive notebook, that those things do not react. The ones on the all the way on the right won't bond with other ones, and the reason is if you look at it, those things all have a full, well, how many valence electrons do the ones already all the way on the right have? 8, except for the first one, which only has, remember how many fit in helium? 2. So they're full. And as a result of being full, they won't react with other elements. So that's unique about these. They're gases. They can be used in like the glow-in-the-dark signs that you see, you know, like neon signs. They're used in headlights. If you've seen those really bright blue headlights that cars have on them that are super annoying when you drive towards them, they're full of xenon gas, so that's in there. But that's it. Those are the ones. And when you got that, that's it.